we're going to dive into a little bit and answer the question, why would I want to be involved with an AI company, and what does zero trust have to do with AI? So first, I'm not going to go too deep into what zero trust is, but let's look at a quick definition, right? So zero trust is a strategy um, designed, a strategy, right? Not a product. It's a strategy to do two things. One is we need to stop data breaches. So this is where this comes in. Data. What is data? You've heard data is the new oil. Why is it the new oil? Well, I live in Texas, so I know that West Texas crude is the benchmark for oil, and there's all kinds of different oil. There's sweet oil and sour oil and shale and all kinds of things. But the other thing, and they have different values, but also data gets and oil both get more valuable as it's refined, right? So if you refine crude oil into gasoline, diesel fuel, aviation fuel, jet fuel, uh, it's the basis of plastics and carbon fiber and nanotubes and all that kind of stuff. It gets more valuable, and it gets more valuable as it's refined into oil gets more valuable that way. Data gets more valuable as it's refined into things that can be used either criminally, right? So if you have a lot of data points, you can do all kinds of cyber crime. You can buy things. You can set up phony identities, or it's for advertising and other purposes, right? So you want to know more and more about advertising, or it's used for surveillance. So data gets refined as well. So we need to stop data breaches. Now, what is a breach? And cybersecurity people get this term confused all the time. We think somebody got into our system, they're poking around, and that's actually the definition of intrusion. Uh, Regulators like GDPR in the EU, CCPA in California, PCI for credit cards, they all say a breach occurs when data that is sensitive or regulated is exfiltrated from our networks or systems into the hands of a malicious actor. It's all about stuff going out, not about somebody getting in. And that's what people misunderstand. The thing about a data breach, it's the only thing that IT can do to get the CEO fired. So if there's a data breach that happens, first of all, you allowed it to happen because you had policies in place that allowed it to happen. And second of all, it probably gets the CEO fired, right? So you look at Target was the first time, Equifax, TalkTalk, Ashley Madison, OPM, the big data breach in the US federal government, all that kind of stuff, right? So the strategy does that. It stops data breaches and it makes other cyber attacks unsuccessful. So there's two types of cyber attacks. One is successful and one is unsuccessful. We can never stop a cyber attack from starting because we'd have to be the malicious actor to do that. But we can make them unsuccessful. And we do that by eliminating this idea of trust from digital systems. So I could go on a long rant about trust inside digital systems, but suffice it to say, it's always a bad thing. Trust, this idea that there are trusted and untrusted systems, is the fundamental root cause of all data breaches. So we must eliminate trust. Now, when we look at zero trust, there's a 5-step methodology on how you deploy it. And you can read about this in the NSTAC report. The NSTAC is the president's National Security Telecommunications Advisory Council. I was appointed by the president in 2021 to serve on the subcommittee for zero trust and trusted identity access. And we issued a report in February of 2022 to President Biden. We would consider that to be authoritative on what zero trust is. So you should take a look at that and read more about it. But the main thing we're doing is figuring out what we need to protect. That's called a protect surface. Define the protect surface. And inside of a protect surface, we put in what are known as DAS elements, DAAS. So that stands for data, applications, assets, or services. So sensitive versions of those things. Now, one of the things that happened is this was originally called define your data. So zero trust was created to make our networks and our systems powerful data security enforcement points, right? So it was initially very data centric. Eventually, I realized that ultimately I could protect other things in there. So we take a single DAS element and we put it into a single protect surface, and we build out our zero trust environments one protect surface at a time. And in this way, zero trust becomes incremental. We're doing it one at a time, iterative, one after another, and non-disruptive. The most we can screw up is one protect surface. So it makes it very non-disruptive. And then we have to understand how the system works together as a system. That's called mapping the transaction flows. Within IT networking, there are packets moving around. Packets are zeros and ones represented by electrons and photons, right? And so that's the entirety of our world, really, if you get down to it, if you deconstruct it. So we want to see how that movement happens, especially in the world of data. And then we can architect the zero trust environment to meet the needs of the protect surface. And this is going to become very, very important related to the data stores that are being used inside of AI models. And so, when we think about large language models, what do they need? They need massive amounts of data. And no one is really thinking about how to protect that data. We're worried about, Skynet going self-aware and creating, the robots that take over the world. But certainly the short-term problem is corruption of this data, stealing of this data, lots of things to do with data. So if we understand that each system has to be architected or designed to meet the needs of the protect surface, we can't just have something generic. And then after that, we need to create policy. Everything happens inside of policy. So you have to have a policy in terms of how you enforce everything. And then ultimately, we monitor and maintain this system. And this allows us to take all the telemetry from the system and re-inject it back into the system so we can make it stronger and stronger over time. This is a concept known as anti-fragility. And so there's a book called Anti-Fragile by Taleb, who wrote The Black Swan, and he gave me the vocabulary to talk about what I was trying to do in digital systems, which was make them stronger and stronger as they get stressed out through attacks or more traffic or whatever stressors go on, that we can make it stronger and stronger over time. So that's how we do this journey. Zero trust is always a journey, and it is generally data centric. So when I was at Forrester, I ran two playbooks: network security, architecture, and operations. That was all the stuff related to network security, and ultimately it's where zero trust came out of. But I also ran data security and privacy. And so I want those two things to interact. And so I created years and years ago a thing called the Data Security and Control Framework. I looked at how data works and how we make a simple framework so we can understand it. So the first thing we need to do is define your data. And that was originally, again, the term before protect surface, defining your data. So what do we need to protect, right? So we have to discover it. We have to classify it. We do a really poor job of data classification, by the way. And then we need to dissect it, understand what's going on. Data intelligence and analytics. This is all of the AI, ML, LLM, whatever term you want to call it. That's happening at the dissect level, right? And so now, once we know what's going on, we can defend it. Define, dissect, defend. Easy to remember. So there are only four things you can do to protect data. You can control access to it, right? Which is a lot of identity stuff. You can inspect that access. What's going on inside the packet? Those two things should be done at the same time, even though they're separate functions. And this is what zero trust does. But again, we can also do other things to data. So dispose of the data, right? I advocate getting rid of data that isn't used. So the last research I saw showed 80% of data in a big data environment is what we call stale. It means nobody's looked at it in the last 12 months. No one's accessed it. And so in general, I would advocate getting rid of that data. archiving it off or just deleting it, disposing of it so that it can't be used by malicious actors. We're going to see people really fight back on that because they want to have all the data in the entire world for these large language models. And there's going to be the law of unintended consequences out of that, because there's going to be some massive data breaches and there's going to be a lot of intellectual property theft, and it's going to be really, really nasty moving forward. And then the fourth thing you can do is kill your data, right? So this is killing it, making it unusable. So the only good data is dead data, in my opinion, from a security standpoint. So you do that through encryption, right? Encrypt as much data as you can. Tokenization, which is an offshoot of encryption, masking that data. And we're not talking about all the data, we're talking about the sensitive data. So things like credit card numbers, PCI, or credit social security numbers, credit card numbers, the sensitive things. You're not eliminating all the data, but you do want to get rid of the stuff that really malicious actors can monetize. And you can also mask data, but in some way you need to defend it. And that's what we're talking about today. And why is this important in cybersecurity? Well, let's look at how fast things are moving. I don't know if you've ever seen the movie AlphaGo. If you haven't, you should watch it. It's a very interesting movie, but it's very informative from a cybersecurity perspective. And this gives us a good example of how we think about things. So imagine this is us. We're playing the game Go. This is the game Go right here. I don't know if you've ever played it. It's a very ancient game, very popular in Asia. I got into it through my son. So we get together and play Go. I've never won a game of Go. He always beats me, but that's okay. And so in this game, it looks like this man, Lee Sedol, right here, is playing this man whose name I forget. He's also a great Go player. But this is how we think about our adversaries. It's one human being against another human being. But in fact, all he's doing is looking at the screen and moving the pieces on the board. This is not two people playing against each other. It's one person playing against a computer system. And that's what's happening in our world today in cybersecurity. We are much more manual and think we're fighting individual cyber criminals when in fact they're highly automated, highly orchestrated, and they can do things much faster than we can do, right? So for example, I don't know if you've ever thought about it, but hackers don't have change control. Hackers do not have change control. So they can just constantly come at you, and you're manually trying to figure out, should we make a change here? And we need to automate this process. Now, this is going to be one of the big benefits of AI and machine learning in cybersecurity. I hear a lot of the gloom and doom. Oh, they're going to be able to make more sophisticated attacks more easily. Yeah, maybe so, but we're going to be able to detect and prevent those attacks more easily using automation and orchestration. So to me, this is the real crux of what's going on related to cybersecurity. We have to be able to make these large language models usable but secure at the same time. And that is a massive challenge. And that takes big brains, like my good friend Sharman, who I'm going to turn it over to right now so he can talk about what we're doing over here at in this model. I mean, he's done so much in the early stages of machine learning, AI, expert systems, and what's happening here to protect these things is really the cutting edge. So take it away, my friend.
Thank you, John. And by the way, before I begin, let me say how big a pleasure and honor it is for me to be here with you because of your past work and your accomplishments. So
thank you. I appreciate that, my friend. And same back at you. This is a guy who was 12 years at Bell Labs, innovating all the things that we use today. So it's cool to hang out with someone like you. Thank you.
I assume the audience can see my screen.
Absolutely. I will validate that.
Thank you, John. So, as John said, AI ML uh, requires massive amounts of data. And the first point I want to make is that very, very few enterprises in the world have the data to do successful AI ML and to do successful AI ML modeling. It does require massive amounts of data. And so where do you get the data from? So here is let me start with some comments from Gartner and IDC. A lot of people are now predicting that there will be a huge emphasis on data partnerships. And to follow John's comments, not just data, but assets, in the sense that even models will be shared, data will be shared. So we are seeing and we'll continue to see more and more data partnerships between corporations happening that allow data hubs to be formed, data partnerships to be formed, sharing of assets, sharing of data, sharing of models, to allow us to effectively use AI and ML modeling techniques. Now, the simple way of thinking about this approach is in AI ML 101, such diagrams are often talked about. And these show the various, at a very high level, the various stages in the AI ML process. So you use the data to train your model training algorithm. And then after an evaluation phase, you deploy the model training algorithm. And during the deployment phase, you then collect runtime statistics, and you use the runtime information to retune the model, improve its performance. You go back through it, training phase, and then you deploy it again. What these pictures fail to show is the complexity at each stage that I have highlighted here. This is not a single stage. These are multiple data flow and data pipelines that happen. And if you blow up these stages, you will see entire multi-stage data pipelines executing in serial and in parallel fashion over a long period of time before the stage is complete. So you have often, so when John says that there are massive amounts of data needed, it means that massive amounts of data are going into the training phase. Massive amounts of data is being collected when the model is deployed. And massive amounts of data is then reused to retrain the models. And now you bring in the notion that these stages that I'm showing here are going to now effectively handle the idea that the underlying assets that you are using in these stages are coming from different corporations. So if you now think in terms of protecting the attack surfaces, these surfaces are not just all in one enterprise. They are spread over multiple enterprises. So how do you now protect attack surfaces that are not only in your enterprise, but are in other enterprises from whom you are either you are sharing to those enterprises, or you're getting assets from those enterprises and using it in your data flows. And that is the complicated challenge of AI ML governance. It is no longer a single enterprise issue. It is a multi-enterprise issue because of the data sharing and data partnerships and asset partnership that are starting to take place. So here is a deeper look at how this world of data sharing and AI and model sharing, the different stages that happen. And I have only started to show some of the attacks that the different stages are going to go through. So there are AI pipeline intellectual property leaks that are possible. There are supply chain attacks and data leaks or data breaches, as John said. There are attacks that poison the data and poison the model. There are attacks using the irregularities leading to model inversion and input manipulation. And there are membership inference attacks where malicious parties may try to infer sensitive data assets that the model may have ingested during the training phase. So how do you protect against these attacks? We have to, of course, remember that AI ML workloads are fundamentally different than regular computing workloads in the sense that they are all heuristics based. Heuristics means that the rules of thumb which are used to do the set of inferences done by a model means that the performance of the model is always questionable compared to the real world. If you run the model twice, you may get slightly different answers. This never happens in a regular workload. Computers are predictable under regular workloads, but the performance characteristics of AI ML workloads are such that you cannot predict what the model will output as the next run of the model. So just to elaborate this further, as data and model partnerships expand, the attack surfaces grow. And AI governance now, there's this new term called connected governance. What we need is the notion that you have a connected governance across all the stages of the AI ML workflows, which spans your data partnership spaces as well. And that is fundamentally a new set of problems, a new set of challenges. These new attack surfaces that are starting to come into being are starting to see new forms of attacks, which regular computing workloads never saw before. And as I said, fundamentally, they are due to the heuristic nature of the performance of these algorithms. So data drift, et cetera, and all these other problems are fundamentally due to the fact that these loads are heuristic. So again, to refer back to what John said, one way to protect your data and your assets is in the form of encryption at rest and encryption in transit. And these are technologies that we have known for a reasonably long period of time. But there is a new set of technologies now that allow encryption in use. What this means is that when an AI ML workload is executing, the model and the data that is being done, the workload could be considered as if it was encrypted. You provide encrypted data and an encrypted model in a protected and isolated computing environment. And these isolated and computing environments are guaranteed by the underlying hardware. A different way of saying this, and this is perhaps what John would like, is that one way to have a strategy of zero trust is to talk in terms of micro-segmentation, where you segment your network into different parts and you protect the segments based on the policies that are tuned to the requirements of that segment. In some sense, what I'm starting to call here as a confidential clean room is the notion that there is a segment in which the workloads execute, and the segment is protected and isolated by a set of policies that are executed by the underlying hardware itself. So the hardware enforces the security policies that are defined for your workload at that point. And so this concept of clean room is becoming a fundamental use, and there are several players in this space. You can think of a data clean room as a place where different parties contribute their assets, and these assets are protected by the policies that are being used in the clean room, and these policies are the enforcement of these policies is due to the underlying hardware enforcing these policies for you. And so if party A provides an asset into the clean room and party B provides an asset into the clean room, and the requirement is that parties A and B do not see each other's data, and the compute happens within the context of the clean room, then the hardware assures that each party's data remains invisible to the other party and from all other parties itself. So the enterprise of data partnerships then means that these clean rooms need to be chained with each other, which essentially means that the input the input to a clean room can come from the output of another clean room. And if this picture looks a little bit like data flows to you, then yes, the stages of such a data flow are the clean rooms. And these are clean rooms. You can think of them as an abstraction layer on top of the data partnerships that you are a member. So I want to emphasize to you that we can use the technology of confidential computing, as it is sometimes called, or of clean rooms, which is an abstraction on top of confidential computing, to provide application security for applications and infrastructure, to protect the new AI ML operational pipelines, to assure the quality of data, and also to prevent adversarial machine learning attacks. Thank you.
So I have a question just to start everything out. I mean, let's talk about the size of these data sets that people are using, right? And how they're different data sets. I mean, does anybody have a single data set? Does OpenAI have a single data set that is big enough to do what they need to do, or are they grabbing data from wherever they can find it?
They are grabbing data from wherever they can find it, John. It is my understanding that unless there are very, very few players who have large enough data to do effective AI ML. So for instance, Google perhaps does. Facebook perhaps does, but not many more than that. So there's a handful of companies that are in the lucky position of having the luxury of being able to collect and aggregate large amounts of data because they have a large base of installed devices, etc., that are collecting the data. However, not many do. Even the healthcare companies or healthcare data providing companies often have to rely on acquiring data from their ecosystem partners. So I don't think a lot of companies have the data that they need to do effective AI ML.
And then when we say acquire, I'm assuming that in most cases, unless it's public data that they can scrape, there's a financial transaction going on here as well. Do you know?
Yeah, particularly in the healthcare space, there is a very healthy market in buying patient data sets. Now, usually when you do these purchases, the PII information or the personal health information, what you refer to as the sensitive component of the data, has been removed, or as is called, anonymized or de-identified. But yes, purchase transactions are very common in the healthcare data market and in the financial data market as well.
And I would assume the advertising data market?
Yes, of course.
So for the average person who's listening or thinking about this, it's not just what is AI going to do to disrupt the world. It's what are the AI companies going to do to disrupt them in some ways, right? I mean, it seems to be a little bit counter to the movement of GDPR and various privacy laws. So how do you see privacy intersecting with these large language models?
Well, 10, 15 years ago, there was a popular sort of a quip that nobody on the internet knows that you're a dog, and that sort of statements were made.
Right.
Nobody today knows what a model that you're using knows about you. It's quite possible that at a future stage, a deployed model is going to start spitting out all kinds of sensitive information because it managed to ingest private and personal information during the training phase. So the entire exercise of private machine learning or privacy-based machine learning is the exercise of how do you either prevent models from learning private and sensitive information, or make the models forget after they have learned such information. And it's a very difficult problem to solve. It's a very difficult problem to solve because in some deep mathematical sense, we don't really understand these we don't understand how neural network deep learning models actually work. We know they work, and they work reasonably well, but we don't really have a mathematical understanding of the details of how they work. And so then to say that we will prevent a model from receiving PII information, or we will make a model forget PII information in some ways or the other, is a very difficult technical challenge to solve. And I see that being as one of the fundamental challenges that happen. The best we can do at the moment is protect the training data and make sure that the model doesn't get poisoned with PII information, etc. So if you can prevent the input data that is being used to train the model, then there is a good chance that the model that you finally deploy is free of, doesn't know a lot of private information. Now, it may still, because of the retuning process that is bound to happen again, it may still end up learning some private information. But a good first step is to control the input data and free it of private and sensitive information.
Well, that's fascinating. Now, this data, though, is it being aggregated into a single sensitive data store or a single data store like ChatGTP, or is it reaching out constantly to its partner data stores? How does that work in terms of aggregation versus reaching out via perhaps APIs or something like that?
It may not get aggregated in certain models. There are different models. So, for example, in the federated machine learning model, you try and not aggregate the data sets and centralize them in one large aggregated data set. You try and develop the model by sending parts of the model to where the data happens to be, and you then run the model where the data is, and then you transfer the weights and the learnings. Let me use the word learnings. You transfer the learnings back to a central place and go to another site of the data and start the training exercise with the new learnings. So in such a federated model, there is no need to centralize and aggregate all the data sets. But in some cases, there is no reasonably effective way not to centralize. So the short answer is you can do various models that are called federated machine learning, which allow you not to centralize and aggregate the data. But if you do aggregate the data, you will have the challenge of protecting the data.
Well, and I'm assuming the cost of storing the data is pretty outrageous for a lot of these organizations, which is why you see the Googles and the really big players doing it more than some small startups.
Right. So use of data lakes and data warehouses, etc., is on the rise, and it's the way to go. Yes.